Weather, climate and water determine people's lives and nations' development. Agriculture, energy, transport, health, tourism, insurance, virtually all socioeconomic sectors rely on information from national meteorological and hydrological services, working together within the World Meteorological Organization. WMO coordinated global observations in the atmosphere, in the oceans, on land, and from space serve any individual and humankind as a whole for making the best choices in the light of current and expected weather, climate, and water resources. It is essential that we upgrade this observing system to help communities everywhere better plan and prepare for natural hazards and extreme weather. Climate change heightens the vital relevance of observing our planet to preserve our environment and reduce disaster risks. Investing in weather, climate, and water observation by the National Meteorological and Hydrological Services is indeed investing in a better future for all.
Our planet's weather, climate, and water systems are unique. They have defined Earth's ecosystems and shaped human society. While we cannot control these elements, we can understand and predict them. Every day, hundreds of thousands of observations of our planet, from space, our atmosphere, the oceans and land, provide us with vital data. These observations are crucial, giving us the tools to survive the worst effects of severe weather and adapt to our changing climate. Over 5,000 kilometers east to west, Indonesia is one of the world's largest countries. Its thriving capital, Jakarta, is home to over 8 million people. This tropical region is prone to the ultimate extremes of weather, from drought to intense storms and flooding. According to scientists of the Intergovernmental Panel on Climate Change, the planet's warming temperatures are likely to make the situation worse, causing rising sea levels and intensifying periods of rainfall. The floods in Jakarta in early 2007 were the worst in living memory, forcing 350,000 people from their homes and costing over $400 million. Around 3/4 of Jakarta's total area was flooded up to 4 meters deep. As in most parts of the world, the city's poorest communities are least able to cope when such disaster strikes. Raina lives on the banks of Jakarta's main river, the Ciliwung. She came here 20 years ago from the countryside, hoping to find work and a better life. In 2007, her house was flooded to the roof. Today, people here are once again at risk.
Banjir tahun 2007 kemarin, semua habis barang-barang. Kan tinggi kan sahabat ke situ. Itu habis. Alat pertukangan pada hilang semua, mesin serut, terus TV, ya semuanya gitu.
Getting early warning of serious flooding can be life-saving.
Semalam kan kabarin Pak RW, katanya 2 meter 35. Tapi saya keluar kalau udah batas itu kunci, terus saya keluar.
The job of predicting when and where the floods will strike is the responsibility of the country's Meteorological and Geophysical Agency, known as BMG. At the main forecasting centre in Jakarta, meteorological observations from land, sea and space are processed and analysed.
This is operational room where we produce daily weather forecast. When we have a heavy rainfall is likely to occur in this area, we send a warning for the people. For flooding, we have cooperated with a water management agency, and then we just produce a flood mapping and flood forecast mapping.
This meteorological information is vital for planning flood defences, new development, energy supplies, and health services. With the sewage system flooded and no clean water, diarrheal disease and dengue fever increase rapidly, especially among children. The planet's warming climate is intensifying rainfall in some areas, but elsewhere it's causing drought, creating serious problems for agriculture and increasing the risk of forest fires. The smoke plume from these fires can cover thousands of kilometers, polluting neighboring Malaysia, Singapore and the Philippines, and even reaching the United States. The Fire Hazard Index produced by BMG scientists places vulnerable areas on high alert. In the Air Quality Laboratory, scientists analyse water and dust samples. Information is passed on to health services and to vulnerable groups so they can protect themselves against the smoke. Predictions of wind direction and strength allow warnings to be issued throughout the region to minimise risks to transport. The work of all meteorological services depends on detailed, continuous observations of weather and climate. The backbone of these are the ground stations, where observers go through a regular ritual of measuring and noting temperature, pressure, humidity, wind strength and direction, and cloud cover. Around the world, there are 10,000 approved sites making observations simultaneously, at least every 3 hours, many every hour. The observations made here at Denpasar Airport are used in detailed local weather forecasts, crucial for the safety of air traffic. But that's not all. Weather and climate don't stop at borders. Through the WMO Global Observing System, observation data is collected not just from ground stations, but from 16 satellites, hundreds of ocean buoys, and thousands of ships and aircraft. Meteorological services around the world are able to share this information daily through the WMO Global Telecommunications System to create thousands of weather reports, charts, and digital products every day. It's a striking example of international cooperation. Observations of weather and climate started in Indonesia many decades ago. At BMG's library, printed archives go back to 1837. Such records can be found in meteorological services all over the world. They form a priceless heritage, providing raw data for the computer modelling used in weather forecasting and analysis.
The predictions is produced by running the model. And for running the model, so we need the data. So it means that the historical data is very important for running the model of predictions.
It's a heritage that continues today, creating the context for long-term monitoring of climate change. Although technology is playing an ever-increasing role in meteorological observation, the human element cannot be overlooked. Throughout the world, volunteer observers provide essential data, working with standardized methods and instruments. 73-year-old Mr. Sutajo is retired. Every day for the past 15 years, he's measured the rainfall on his roof in the suburbs of Jakarta and sent his record back to BMG analysts. Information which helps create the flood predictions and risk maps, which are life-saving. More than half the world's people live near the coast. Here, weather observations can make the difference between life and death. Fishermen and sailors in every region of the world are at the mercy of storms and high seas. For local fishermen in Bali, knowing the weather forecast is a daily routine. But there's another danger. In 2004, a massive undersea earthquake triggered a tsunami that inundated thousands of kilometers of coastline around the Indian Ocean. Over 250,000 people lost their lives. Since the disaster, a multi-hazard early warning system is being developed with an international network of seismographs. The Indonesian coast is also protected by 18 early warning sirens.
Kurang dari 10 menit, informasi itu harus sudah kita diseminasikan ke satlak, ke instansi terkait yang terhadap kegiatan dan kebencanaan. Jadi paling tidak tsunami itu bisa sampai di pantai adalah kurang lebih 30 menit.
Earthquake 20 hours, 21 minutes ago, south of Java, Indonesia.
Like a number of weather services because of their operational experience, the Indonesian agency is responsible for earthquake and tsunami monitoring and warning. The Earthquake Center receives data from countries all over the region. The monitoring network is coordinated by IOC UNESCO, but tsunami observations and predictions are shared internationally through the WMO Global Telecommunications System, so warnings can be issued in just minutes. Away from Bali's tourist centres, the rhythms of the island are ancestral. The farmers share the work of ploughing and planting the country's staple food, rice. While flooding is affecting some parts of the region, here it's the opposite problem. In recent years, farmers and climatologists in southern Indonesia have seen a drastic decrease in rainfall. Without enough rain to irrigate the rice, the crop will fail.
Ya, kalau perubahan iklim sekarang ini sudah terlalu panas iklimnya panas sekali begitu. Tapi masalah di sawah ini karena kekurangan air.
The decrease in rainfall has been disastrous.
Ini masalah itu kekurangan dan karena gagalnya panen gitu. Memang betul sebagai petani semua termasuk saya juga kurang untuk makan gitu, apalagi untuk menyekolahkan anak-anak itu sudah kurang dia gitu kan.
Agriculture is particularly weather sensitive. Communities in many parts of Africa and Asia are facing crop failure brought on by changing weather patterns. Climatologists realized the farmers needed help. They used detailed meteorological observations to analyze local weather and climate. With the Ministry of Agriculture, monthly information sessions were started, helping farmers understand the forecasts and make the most of what little rain there is.
Kondisi sudah berbeda. Dulu para petani menggunakan tradisional, sekarang sudah ada teknologi. Dengan teknologi kita dapat memprediksikan lebih baik. Apabila petani tahu bahwa kondisi yang akan datang itu sesuai dengan prediksi kita, maka para petani kami harapkan dapat melakukan pola tanam yang lebih baik. Dengan demikian hasil pertaniannya akan lebih baik.
The scheme is new in Bali, but in the islands of Sumatra and Java, pilot climate field schools have been running for 3 years. They've helped farmers to increase their yield from 4 or 5 tons a hectare to 8 tons. It's been so successful that the scheme is being expanded to 50 more sites. The rice farmers here have high hopes. Observations of weather and climate are making a real difference to many farming communities, helping them adapt to changing weather patterns. At a global level, the World Meteorological Organization unites national meteorological and hydrological services in a coordinated network to share observations and predictions. These shared data are the bedrock of our understanding of weather, climate, and water. As we learn to adapt to the Earth's changing climate, it's vital that we invest more in our meteorological and hydrological observation systems in order to improve that understanding and bring about a better and safer future.